Hi, welcome to Computing 120 mock final exam. Unlike the last one, which focused on binary searching, recursive algorithms, and those harder questions, this one is more of a general overview of the entire course, and there might be some easier problems as well. There are actually 4 questions, but I actually added 2 other questions in the end as well. But let's get started with question number 1. Convert 1001 base 2 into a decimal. So when we're dealing with other base numbers, what we usually do is we take the digits and then multiply it by whatever power of the base. So here, let's start off with the last digit. So we're going to have 1 times 2 to the 0, plus 0 times 2 to the 1, plus 0 times 2 to the 2, plus 1 times 2 to the 3. Notice here my exponents are increasing by 1 every time. It's very similar to how we would deal with decimal numbers, except that this time we're just working with the bases have been changed into base 2 rather than base 10. So here, now this is just our regular addition, so we can just simplify it like how we would add it. This would be 8. These terms cancel out, and then we have 1 left as well, so it'd be 8 plus 1, or 9. So our correct answer is A. Question number 2, this was actually a trick question. For those of you who didn't do their readings, you probably get this wrong, but remember that strings are immutable. What immutable means is that we cannot change it. So notice that lists are mutable. So when we have like 1, 2, 3, 4, and then I want to change the 4th index, for example, I can do that. But I can't do this with strings, so therefore I would get an error in Python. Question number 3, however, is a bit different. Notice here I'm creating a new string rather than just trying to change my original string. So when I have greetings from 1 and onwards, what I'm doing is look at the index. It starts at 1, so I'm going to go to index 1 over here, and then everything after this is going to be captured by my code. So I'm going to have LO and then world like that. But notice I'm going to be adding J to the beginning of that. So it's going to be Jello world. So choice A. Question number 4 is actually a past midterm question, or I expect that it'll be on the midterm. Now let's take a look at what this code firstly does before we actually try to solve it. Import turtle, I feel like everyone knows that. Here we define a function called draw, and notice these are our inputs of the function. And our base case, or when we break the function, is when a is less than 10 or when b is less than 10. So this would kind of be like our base case, but we don't return anything really. What we're doing here is alex.left b. So notice here, we're using b as an angle. This is really important. And we're getting alex to go forwards by a. So notice how a is being used as the distance, while b is being used as the angle. Here we make a recursive call. This is a key point. And then let's analyze the rest of the code later on. So the above code draws a tree using turtles. Notice in later computer science courses, a tree would look something like that. And what our code is actually doing is drawing a tree like this. Let me show you how that works step by step. So our 2 inputs are 100 and 35. So let's get started. So my turtle starts off here, this dot, and then alex.left b. So if we're facing this way, my alex is going to go 35 degrees like that. So my alex goes there. And then now what do? Alex needs to go forward by a distance of a. So it goes forwards by a distance of 100. And then I make a recursive call. Okay, so I subtract my 2 numbers, a minus 10. A minus 10 would be what? 90, and then b minus 10 would be 25. So what I'm going to do from this point, notice my turtle is still facing this way, is I'm going to turn left by 25 degrees now. So my turtle is actually going to face slightly that way, and then go forwards by a distance of 100 by 90 this time though. So I go 90, and then what I'm going to do next is I'm going to subtract 10 again. So I get 80 and then 15. So similarly, I go 15 here by a distance of 80, and then now my turtle is here. And then the final recursive call, I subtract 10 from each of these again, so I get 70 and 5. But notice I have reached my base case, so I stop here. Okay, so now I'm going to back, so I'm going to go back, and then I'm going to go backwards by A, so by 80, and then I'm going to turn left by minus B degrees, which is going to get me back here. And then what I'm going to do is I'm going to go back once again, so I'm here again. Oop. But now notice I actually have, once I come back and then go left, so I'm here facing that way, I have to go right by B degrees, so right like that. So notice here I'm actually creating two branches like that. And then I'm also going to have a recursive call here, but notice our recursive call is going to be our base case, so I stop here. And I go backwards by A once again, and then right. So now right by B, so I'm here. And then it's going to go back here. So this question is actually kind of complex in a way that each recursive call will actually make two separate calls. So I've drawn out one branch over here, but then what this code will actually do is go one more and then draw two more branches. And then from this branch, I have to draw two branches. So branch 1, branch 2, separates into two other ones, and then separates into two other ones like that. So in total over here, I have 1, 2, 3, 4, 5, 6, 7, 8 branches in total. So that's why our answer is 8 for this code. Let's take a look at question number 5. Refer to code from question B. What does the variable B represent? So notice here that B was our angle, the angle at which I turned out. So if I have my turtle over here, this angle was represented by B. The speed is obviously wrong. The distance was A. The branches, we figured that in the last question, so our correct answer would be D, the angle at which the turtle turns at. Question number 4, what does the variable A represent? The speed is wrong. The distance is correct, as I've said before. This is not, and that was B. The time complexity for the code in question 4 in terms of A and B is. So each iteration, this one's a hard question, our variable A and B would decrease by 10. So minus equals 10 every time, basically. And how many times would A and B have to decrease each time to get to 0 or below 10? The correct answer for that would be A divided by 10, or B divided by 10. Now what I'm going to do is, whichever one is smaller is what I'm going to be dividing by 10. So I'm going to have to take minimum of A and B, and then divide this by 10. But notice, as I've said before, each recursive call will make two calls. And as said in this last practice question document, this would be an example of an exponential time complexity. So here I would actually need to raise 2 to some power, and that power over here would be minimum of AB over 10. So our time complexity can be represented by O of 2 raised to the minimum of AB over 10. However, notice that this is equal to O of 2 times min of AB times a constant factor of 2 times 1 over 10 by exponent loss. And remember what the professor said about constant factors is that this would actually cancel out. So we're just left with O of 2 raised to the minimum of A and B. Let's take a look. So that's our final answer. So let's take a look at question number 8. This question is fairly easy. So I would go from 3. So this was our start, and this was our end, and then that is our step. So I starts at 3, goes to 5, goes to 7, goes to 9, does not go to 11. But then J here is a little bit tricky because we're using I here once again. When I is 3, so we're going to have J in range of 3 to 5, which is perfectly okay. So we're going to do that. And we're going to get 3 and then 4, but we don't go to 5. So we know that C is wrong. And then let's take a look at what happens when I is 5. When I is 5, we actually don't do anything because the start is equal to the end. When I is 7, we're not going to do anything. When I is 9, we're not going to do anything. So our answer would be A. Question number 9, palindrome checker. Ooh, this one's actually a kind of trick question as well. So, first of all, if this question asks, does this function work? The answer would be no, because we never return true. So this could be a question on the final exam. We don't return true. So there's no we can only check if it's false. We never check if it's true though. So to fix that, we will need to return true at the end here. But otherwise, what we would do is, for I in range of length of word, so length of word here is 5, divide integer division 2, this would be 2. So for an I in range of 2, what I'm doing is I'm checking the ith index, so A. So I would start from 0 and then go all the way up to 1. And I'm checking if that is equal to the length of the word, which is 5, minus I. What was I right now? I starts from 0, so 5 minus 0. Notice here, though, the maximum index, so the max index would be equal to 4. And what I'm trying to check is 5 minus 0, which is 5. So we actually get an out of bounds error, so this would be choice number C. To fix this code, however, we would need to take away 1 from here. So length of word minus I minus 1. Question number 10, images are represented as a 3D list, obviously. Notice, if I have an image like that, let's say, it's a bad drawing, but each of these little squares represents a pixel. And notice this entire image is actually a 2D array or a 2D list. But then since each pixel is represented by a list of RGB, this turns into a 3D list rather than a 2D list. So this question is actually also tricky, and this is for aliases. If we print function of myList, where myList is a list of length n with the positive integers, what will the code print? So here, notice this is the crucial line. New list is a list. This is a list alias rather than list cloning. To fix this, we would actually need to have a list and then colon like that. But let's take a look at what this code does. For I in range of length of new list, we're just simply adding 2 onto the new list. Add 2. Very simple. The difference is an empty list, and therefore j in range of new list. What we're going to be doing is we're going to be doing new list minus a list. But notice new list is a list, but then we just simply added 2 to every list. But when we add 2 to new list, what we're doing is we're adding 2 to a list as well. So since new list is a list, all of their differences would be equal to 0. So all the elements in difference would be equal to 0. Now at the end, we're returning the sum of difference, but we know that that's simply 0. Now, some of you may have thought that the correct answer was a is equal to 2n, but this is completely wrong, as this is an alias. If we had new list is equal to a list, but then we're cloning it, the correct answer would have been a. B and C just makes no sense at all. The difference between append and list concatenation is appending a list modifies the original list, while list concatenation creates an entirely new list that contains one element. So everything up till here was fine. So this is all correct, but then this is completely wrong. So our answer choice A is wrong. Appending modifies the original list, yes, while list concatenation uses a new variable name. Doesn't quite have to be a new variable name. Doesn't have to be. Appending changes the memory location of the list. No, because the list is still in the same. We're just changing the original list, and the memory of the original list is never going to change. Appending does not change the memory, yes, while the list concatenation changes, yes, because we're creating an entirely new list. So the correct answer would be D. Question 13 to 14, this is a selection sort problem. Let's take a look. The above code. So for fill slot in range of length of a list to all the way to 0, so if you have 3, 9, 2, 1, 5, 6 like that, I'm scanning backwards, so iterating backwards. Position of max, so obviously this variable represents the maximum variable for location and range of 1. So we start at location 1 all the way to fill slot plus 1. So fill slot is right now the last element, so all the way to here. What I'm going to do is if a list of location, so if this one is greater than the position of max, which is right now 0, position of max is location. So this one is obviously greater than 3, so position of max would be this one. Let me let green represent position of max. It's this one now. And then I check the next one. 2 isn't greater than 9, so we don't move it. 1 isn't greater, 5 isn't greater, so position of max is 9. So we found our max position, which was position number 1. Okay, but now this is the bad part. This is actually directly copied from textbook, but I've just tweaked a few parts of it. A list of fill slot is equal to A list of position max. We've talked about this in class. We can't switch variables like this. So this will not work. So when we do this, our value of the variable is actually lost in there completely. So let's take a look at our answer choices. Does not work. This clearly works. This works as well. So our correct answer is C. Will the above code still work if the code for fill slot in range and length of A list minus 1? So notice that there's this error, which was not talked about in this question, so our correct answer would be D. All of the following are good reason to use functions except, so we can reuse, yep, and no, it does not improve the time complexity. So this code is using turtles once again. The function AB will, this was just a very simple question. C is equal to B plus 100, counter 0. Each iteration, what we're doing is we're increasing the variable C. Increase C. So what's happening is we're going forwards by C, or sorry, increase counter, I mean. So each iteration, I'm just going to go forwards like that, and now I'm going to turn left. But kx starts from 0, 1, 2, 3, but then counter would start at 0 as well. But counter increases every time, very similar to how kx increases. So we go from 0, 1, 2, 3. So I'm going to go left once again. So each time this would simply be 0. So this was just there to confuse you, basically. So I go left, and then I go forwards once again, and then I go left. So this would actually draw a square. Very simple. Angles with 90 minus kx. This isn't quite the best answer, but I guess it could be correct. But C is the best answer. Randomly, no, there's no random. Kx cannot be used in a for loop. Nope, this is, if you chose this one, go review your for loops. The variable Alex is, since we're defining Alex outside of the function, this is a global variable for any type of variable that we're defining outside the function. Fruitful, notice fruitful, we have to return a value. There's no return here anywhere, so obviously it's not fruitful. The following code prints, notice, if we have A like that, we can add A to the the first element, so we come 3, 4, 5. And then all I'm doing is adding 2 to the end of the list, 3, 4, 5, and then 7 like that. And then when I append it, notice I cannot do this. It's not going to be a syntax error, but it's just going to print none again, because we're defining something to a function, which is possible, but this would just simply lose our value, so our correct answer would be D. It actually states this in the textbook as well as the notes, I'm pretty sure. List aliases refer to the same place in computer's memory. This was talked about in question number somewhere. I've mentioned this in other questions, and this is true. This is actually not covered in, I didn't post this in the Discord server, but video streaming uses 32-bit integers. Notice bit represented 0 or 1 to count the number of items, blah, 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 blah. Which of the following best describes the result of using 64-bit integers instead of 32-bit integers? Notice, when we have 32-bit integer, we can store 2 to the 32. Why? Because each bit can be 0, 1. So if I have 32 columns like that, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. There are 2 options for each bit, and there are 32 bits. So from discrete math, we can use the multiplication principle and get 2 to the raised to 32. Similarly, 64-bit would be 2 to the 64 instead. If we divide these two via exponent laws, we get 2 to the 32, so our correct answer is C. ASCII, I don't know if you pronounce it that way, is a character encoding, blah, 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 blah. You guys should all know how to use this table by now. So, which of the following letters is represented by the hexadecimal? So this question is nice because it incorporates ASCII as well as base 16 numbers. Base 16 number 56 would be 5 times 16 plus 6 times 1. So notice it would be 16 to the 0 actually, would be 80 plus 6, which is 86. So I take a look at what 86 corresponds to, which is V. So our correct answer would be C. Oh, I forgot to insert the picture on this one. Let's skip this one. But the last two questions are from the AP Computer Science Principles course if you're interested in that. Question number 22, this is a free response question. F of x would just simply square a number. The above code's intention is to return a squared value of a user's input. Does the code work? If not, explain. So it doesn't. So the reason I put this is obviously it doesn't work for some reason. Notice here, I'm not taking in the integer. I have to convert it explicitly. So this was kind of a trick once again. And I'm pretty sure this was tested on the midterm as well, so highly good chance that this will be on the final as well. Now, the other error is that when we take in the user input, I'm going to have test in a new variable be an alias. Once again, alias, this is a key concept. Many of you will go into the final exam and look at this part of the code and forget what an alias is and then answer this question wrong. So I have to list out what's wrong with the code. First of all, line number, let's say 3. Line 3 is wrong because we need the integer here. Secondly, this is an alias. We need to create a copy of that variable. When I use function of user in and then I square it, notice my x is changing, but then since my input's changing, user in also changes, but then test in also changes. So when I print before, let's say that my input is 10, before is 10, and after it's going to be 100, it's actually going to change test in as well. So test in is going to be 100 as well. So these are the two errors within my code. Question number 22. What question number 22 basically asks is, we have some coordinate pairs like that in myfile.csv, and I want to print the maximum distance. This is something called brute force or complete search or linear search. What I'm going to do is I'm just going to solve part A for you guys. I'm going to have two for loops for I in range of what, let's say n, and then I'm going to have for j in range of n. I'm going to keep a maximum distance variable, very similar to how I would find the maximum distance or the maximum number in a list. And that maximum variable should always be initialized to a really small number, negative 100,000, let's say, or whatever. And I'm going to calculate the distance between 2 points. Calculate distance between the 2 points. And I'm going to check if distance is greater than the maximum, what am I going to do? I'm going to update the maximum, very similar to how we solved the maximum in a list problem. Maximum is distance, like that. Question number 25, I have, what was this? How many distinct integers there are? So many people, I'm pretty sure, what they would do is they taken the inputs here, and then they sort it. So the sorting takes O of n squared complexity, and then they try to count how many, right? But then this code will not work. Why, you might ask? Or actually, sorry, this code will work, but then the time complexity will be a little bad. After I sort it, what I have to do is I have to go through the list again like that. So this is O of n squared plus n, which is O of n squared. But a better way to do it would be to take in the inputs. And then as we're taking in the inputs, I'm going to have a new list called found and an empty list. And then for I in range of n, I'm going to append the input into found. But before I do that, what I'm going to do is I'm going to check if input is in found, then we know that this isn't a distinct integer. So I don't do anything here. But else, I'm going to increase a counter. Counter plus plus. And then what I'm going to do is at the end, I'm going to append something to found. Found.append. And then the input. Because we know that the input exists. But here, this is time complexity O of n squared. Why, you might ask? The for loop here is n. notice that the in function here is actually also n, so it'd be n squared, which is the same as this one, but notice we aren't doing O of n squared plus n, so we're getting rid of the plus n factor. And yeah, that's it. Hope you enjoyed my video.